Okay, LAM, oh, excuse me, LAM4. So in this problem 4, what we're doing is we're looking at the problem, these matrices from the previous problem. So we've got those numbers and then this vector here that'll come up later. And all I want you to do is to compute this matrix product in different ways and observe that you always get the same thing. And just to sort of a sanity check to make sure students realize that these different interpretations of matrix multiplication are in fact all the same and all work. So there's 4 different ways that you're going to do this, right? And it's a little tedious, especially the first one. This first one is really, really tedious, right? But we're just effectively just multiplying the 2 matrices. So let me walk through this first one. Okay. So interpretation 0 says that this product is the matrix representing the linear transformation. That's the composition of the 2 transformations that are shorthanded by these matrices. So the very first thing I've got to do is write down those linear transformations. And here we go. Let's see here. Here we go. Okay, so what is this linear transformation? Let's see. Let's call it T of XYZ. And I want that to be A, X, Y, Z. So in other words, this matrix, A, above there, that matrix is the shorthand for this linear transformation, T. And here's the formula for it. It's, of course, A times X, Y, Z. So it's that matrix up there times X, Y, Z. So it's negative 2X plus Y plus 0. And then 3X minus 2Y minus 4Z. And then negative x plus 2y minus 1z. So I claim that this is the linear transformation that's shorthanded by A. Is that cool? All right. And then ditto for, there's a linear transformation S of, I'm going to say UVW given by B. And then UVW, and you'll notice I'm not using XYZ here because I'm going to be composing, and compositions are confusing if you confuse your variables. So this is, okay, let's see here. Well, it's, let's see, UVW, so 5U minus V plus 2W minus 2U plus 5 V plus 4W, and then let's see, 5U plus 2V plus, well then 0W. Okay, so there's our 2 linear transformations. And now we want to compute the product. Let's see, I've already forgotten. We want to compute the product AB, and I claim that AB, let's see here, is what you multiply by something to get T compose S of that thing. So this is the definition of a matrix product. Is it's the product matrix is the matrix that corresponds to the composition of the 2 linear transformations. So I'm going to brute force compute this thing here. And here we go. It's a little effort here, but so we're going to be taking T of S of U. All right, so we're going to be taking T of, yikes, okay, S of U. Well, here's S of U is all of this jazz here. Okay, so deep breath. All right, so 5U minus V plus 2W, negative 2U plus 5V plus 4W. 5U plus 2V. This, by the way, is your X, that's your Y, and that's your Z, because these are the 3 things that I'm plugging into T. X, Y, Z. So when I plug these things into T, this is my X, etc. All right, so when we write this down now, this is... yikes. This is going to be a lot. Notice how I left myself a lot of space here. Okay, the formula for t is the first component. This first component up here is going to be negative 2x plus y. So it's going to be negative 2 times that plus that. Okay, so negative 2 times that plus. Okay, so negative 2 times. I see what I'm saying. There's a lot of, yeah. So 5u minus v plus 2w. And then plus, let's see, negative 2x plus y is, plus y, which is this. This is negative 2u plus 5v plus 4w. Which, now by the way, we've got other components to do, but once I do those other components, this is going to simplify. Let's collect terms. I've got apparently negative 10u there. Another minus 2u. Altogether, I've got negative 12u. How many v's do I have? Well, I have plus 2v plus another 5v. So that's plus 7v. Let's see here. And then I have minus 4w plus 4w. Oh, okay, so plus 0w. How about that? Well, I'll put plus 0w. And then keep going, right? So you got to do here, you're going to have the formula for t. The second component is 3x minus 2y minus 4z. Okay, so x is 5u minus v plus 2w. Y here is minus 2u plus 5v plus 4w. Z here is 5u plus 2v. And you got to multiply that all out and collect terms, and that'll give you, something u, and then something v, and then something w. And you got to figure out what those. I'll let you work out the rest of those details as to what those numbers are. But the point is, you brute force compute the composition. But, just plug in, literally, and notice what you're going to get is going to be, in fact, a matrix. It's going to be a linear transformation that you can shorthand as a matrix. And so this is going to be, all together, I can write that as a matrix times UVW. And we've got a negative 12, and a 7, and a 0, and there's going to be other stuff that you can, determine yourself. And this is the matrix AB. There, that's that. Okay. So a lot of tedium, right? I'll let you work out the details. But ultimately, when you're doing, I want students to realize that when you're doing a matrix multiplication is composition of linear transformations. It is going to accomplish exactly this. Now, the great news is you never have to do this ever again as long as you live. Right? After you've done it this once on this one exercise. Because the next thing that we observe, let's see here. Next thing we observe is that you can compute the exact same product matrix by using these other interpretations of matrix multiplication. And so let's do that for one of these.
I'm sorry, I have a question.
Yeah.
So at the top, when you're solving.
Up here?
You said you shorthanded, no, like a little bit up.
Oh.
So you said like you shorthanded like the linear transformation. So
yeah.
Like it's really like, I guess, the standard basis vectors, like those.
Yeah, well, okay, yeah, sure. You're right that negative 2, 3, negative 1, that's going to be the image of the first standard basis vector by t, sure.
Okay, you just didn't write it out like in that form. Like,
Yeah, I'm writing it out in sort of the formula form, the most sort of, yeah. Well, yeah, but you could argue that what I've done is I've taken the matrix A, which is sitting right up above there, and I just literally multiplied it by x, y, z, which is the same as doing that linear combination thing, right? So I've taken the matrix A, multiplied by x, y, z, and I claim this is what you get. Yep. Okay, now let's do this an easier way. And keep in mind, this is recording, so you can, let me just go on to the easier way to do it. And by the way, if you want to, you can have that if you want, or you can. Andre might want to copy it from you or something. But So let's see here. So the next thing we're going to do is we're going to use interpretation 1. So I'm going to multiply A times B. Let's write this down. So I got negative 2, 1, 0, 3, negative 2, negative 4, negative 1, negative 2. Oh, that's a positive 2. Oops. Negative 1. Okay. 5, negative 1, 2. Negative 2, 5, 4, 5, 2, 0. So interpretation 1 is that the product is made up of 3 columns, of course. And each column is a linear wait a second, which way is each column is a linear combination of these 3 columns, where you use the corresponding column over here as your coefficients. So this column, this first column is going to be a linear combination of these 3 columns, and I'm going to use this column as my coefficients. So I'm going to take 5 times that column, negative 2, 3, negative 1. And then this is by using interpretation 1. Yeah, that's right, exactly. And then I've got negative 2. Let me make that a negative 2 times this second column here, which is 1, negative 2, 2. And then plus 5 times, and then this last column, 0, negative 4, negative 1. And so you can, same sort of thing for these other 2 columns. This is going to be, again, be a linear combination of these using this column as your coefficients. This is going to be a linear combination of these columns using that column as your coefficients. But again, you can multiply this out. This is just arithmetic at this point. And this first column then ends up being, well, let's see here. I'm just going to add these up. I've got negative 10 and then minus another 2 makes negative 12. That's good. That's the same thing we got in the last one, doing it the other way. And then I can just keep computing. So there's a 15 plus 4 makes 19 minus 20 makes negative 1. And then, let's see here, negative 5, negative 4, and another negative 5, that makes negative 14. I hope I'm doing the arithmetic right here. By the way, if I get the arithmetic wrong, forgive me. So this is what I want you to do for that second part. You're just computing by interpretation 1. Then by interpretation 2, that's where you use dot products to compute individually. And then interpretation 3, you're doing linear combination of rows of the right matrix instead of columns of the left matrix. Does it all make sense? Okay, cool. Any other questions about this problem? Is everybody happy with this problem? Okay, great. Let me stop this.